Hi, John Marsh here, and in this video I am going to do one or two problems from Homework 7. The Homework 7, there were several problems that I didn't get to when I went over them in class. And so the first one is number 6. The top two rows of Pascal's triangle contain only ones and are considered rows 0 and 1 respectively. Complete Pascal's triangle through row 8, and for each row write down the sum of the numbers in that row, and based on the pattern you see write down the equation that gives the sum of the nth row of Pascal's triangle. So let's go ahead and do this. This is homework 7, number 6. Okay, and I'm going to make Pascal's triangle here. How about if I start it over here? So as it says, the first two rows have nothing but ones in them, and then we end up with a 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And again, the pattern here is that I add the two numbers above to get the next number down. So I add the 1 and the 2 to get a 3, the 3 and the 3 give a 6, the 3 and the 1 give a 4, etc. So I always have a 1 along the edge. 4 and 1 is 5, 4 and 6 is 10, 10 again, 5, and another 1. Now I have a 1, 6, 15, 10 and 10 is 20, 10 and 5 is 15 again, and a 6 and a 1, 1, 7, 21, 35, 35, 21, 7, and 1. So these are rows 0, 1, 2, 3, 4, 5, 6, 7, and we're supposed to go through row 8. Oops, sorry, that's off the edge there. Sorry about that. And so row 8 has a 1, 8, 28, 56, 70, 56, 28, 8, and 1. Okay, so this is Pascal's triangle through row 8. And what it asks us to do is to sum these rows. And so I'll do that over here to the left. And the sum of row 1, or row 0 is 1. The sum here is 2. 1 plus 2 plus 1 is 4. 1 plus 3 plus 3 plus 1 is 8. 5 plus 5 is 10, plus 6 is 16. Do you see the pattern here? We're doubling it each time. 1, 2, 4, 8, 16. 16 and 16 is 32. We have 1 plus 6 is 7, plus 15 is 22, plus another 22 is 42, plus 20 is 22, and 22 is 44, plus 20 is 64. And you can believe it, the pattern goes to 128 and 256. In other words, the sum of the binomial coefficients, these are binomial coefficients, in Pascal's triangle, the sum of the binomial coefficients in any given row is equal to 2 raised to that row number. So in row number 0, I had 1 is equal to 2 to the 0 power. In row number 1, 2 is equal to 2 to the 1 power, and so on. 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, and 64 is 2 to the 6th. Okay, so that's the result there. Based on the pattern you see, write down the equation that gives the sum of the nth row of Pascal's triangle. Okay, sum of the nth row of Pascal's triangle is 2 to the n. Okay, and this makes sense because The nth row of Pascal's triangle, for example, let's take row 4. The elements in row 4 are C4, 0, C4, 1, C4, 2, C4, 3, and C4, 4. Notice that there are 5 elements in row 4, and I have 5 elements here. These are the 5 elements in row 4, and in fact, C40 is the number of 0 element subsets from a set of 4 elements, 4 objects. C41 is the number of 1 element subsets from a set of 4, and that is 4. C42 is the number of 2 element subsets from a set of 4. C43 is the number of 3 element subsets, and C44 is the number of 4 element subsets. And you can see that those numbers work out correctly if you write it all out. And in fact, if we add these 5 numbers together, we're going to get the total number of subsets of a 4 element set. Okay? And we know from our binary number trick that we talked about in class that this is in fact 2 to the n, or 2 to the 4th in this case. Okay? So, hope that helps. That's number 6 from homework 7.